Hello and welcome to InsideWi-Fi, Video 13. How 802.11b or Wi-Fi 1 unleashed wireless for everyone. In the previous video, we explored the original IEEE 802.11 standard, the foundation of wireless networking. But there was one major problem. The original 802.11 was slow. With maximum data rates of just 1 or 2 megabits per second, Wi-Fi was still far from becoming a mainstream technology. Then came 802.11b. Approved in July 1999, 802.11b, or what many people call Wi-Fi 1, marked a major leap forward in wireless networking. It delivered higher speeds, better reliability and improved accessibility. And most importantly, it helped bring Wi-Fi into homes, businesses and public spaces around the world. So, how exactly did 802.11b unleash wireless for everyone? Let's find out. Key characteristics of 802.11b. Let's begin by looking at the key characteristics that made 802.11b so important. Maximum raw data rate. The first major improvement was speed. The original 802.11b standard supported only 1 or 2 megabits per second. 802.11b increased the theoretical maximum raw data rate to an impressive 11 megabits per second. That's a significant jump. But 802.11b was also designed to handle less than perfect wireless conditions. If the signal quality deteriorated, the device could automatically fall back to lower data rates, 5.5 megabits per second to 2 megabits per second, or even 1 megabit per second. This meant the connection could continue working, even when wireless conditions were not ideal. The speed might decrease, but the connection did not necessarily drop completely. Operating frequency band. 802.11b operated exclusively in the 2.4 GHz industrial, scientific and medical, or ISM band. One of the biggest advantages of this band was that it was unlicensed. In simple terms, manufacturers could develop and sell Wi-Fi equipment without requiring an individual radio license for every device or user. This made wireless networking much more accessible. And this accessibility played a major role in the widespread adoption of Wi-Fi modulation technique. So, how did 802.11b achieve higher data rates, while continuing to operate in the same 2.4 GHz band? The answer is complementary code keying, or CCK. CCK is a more advanced form of direct sequence spread spectrum, or DSSS. If you remember from our previous video, DSSS was one of the physical layer technologies, supported by the original 802.11 standard. 802.11b built upon this technology. By using CCK, 802.11b was able to achieve higher data rates, within the same 2.4 GHz frequency band. Channel bandwidth. Here's a very important point about 802.11b. The 802.11b standard used a 22 MHz channel bandwidth. This is often confused with the 20 MHz channels, used by later standards such as 802.11g and 802.11n. And here's the interesting part. The channel center frequencies were spaced only 5 MHz apart. Because the channel width was much greater than the spacing between center frequencies, the channels significantly overlapped with one another. As a result, in regions such as North America, only 3 channels were considered truly non-overlapping. These were typically Channel 1, Channel 6, and Channel 11. This channel arrangement became extremely important when deploying multiple access points. Real-world throughput. 802.11b supported a theoretical raw data rate of 11 megabits per second. But did users actually get 11 megabits per second? Not exactly. In real-world conditions, the usable throughput was lower. Why? Because wireless communication involves protocol overhead, acknowledgements, retransmissions, and shared access to the wireless medium. For TCP traffic, typical usable throughput was around 5.9 megabits per second. With UDP traffic, throughput could be slightly higher, approximately 7.1 megabits per second. So, remember, theoretical data rate is not the same as real-world throughput. Range. 802.11b typically offered an indoor range of approximately 30 meters, or around 100 feet. Of course, this was only a typical value. The actual range could vary significantly depending on the environment. Walls, furniture, interference, and other obstacles could all affect the wireless signal. But for many homes and small businesses, this range was practical. Media access control. Now let's look at how devices share the wireless medium. Like the original 802.11 standard, 802.11b used CSMA. That stands for Carrier Sense Multiple Access with Collision Avoidance. In simple terms, a wireless device first listens to the channel before transmitting. If another device is already transmitting, it waits. This is extremely important, because multiple devices share the same wireless airtime. If several devices transmit at the same time, their signals can interfere with each other. CSMA helps coordinate access to the wireless medium and reduce the chances of collisions. Adaptive rate selection. Another important feature of 802.11b was adaptive rate selection, or ARS. Let's imagine your device is connected at 11 megabits per second. Now, you move farther away from the access point. The signal becomes weaker. Or perhaps interference increases. Instead of immediately dropping the connection, the device can automatically reduce its data rate. It may fall back from 11 megabits per second to 5.5 megabits per second, then to 2 megabits per second, or even 1 megabit per second. The connection becomes slower. But it remains usable. And this was a very important concept in early Wi-Fi. A slower connection is better than no connection at all. Interference susceptibility. However, 802.11b also had a significant weakness. It operated in the 2.4 GHz ISM band. This band was shared with many other devices. Microwave ovens, cordless phones, and Bluetooth devices could all contribute to interference. This interference could degrade Wi-Fi performance and reduce the quality of the connection. So, while 802.11b helped make Wi-Fi popular, the 2.4 GHz band also introduced its own challenges. Impact and legacy. 802.11b was instrumental in popularizing Wi-Fi. It offered significantly better speeds than the original 802.11 standard. At the same time, the cost of wireless equipment was falling. Together, these factors made wireless networking a practical and attractive option for homes, businesses, and public spaces. 802.11b helped transform Wi-Fi from an emerging technology into a mainstream networking solution. Its success laid the foundation for faster Wi-Fi standards such as 802.11a, 802.11g, 802.11n, 802.11ac, and 802.11ax. In many ways, 802.11b was the standard that helped Wi-Fi become Wi-Fi. Security. But there was one more important aspect of wireless networking: the security. As Wi-Fi became increasingly popular, protecting wireless communication became more important than ever. And the security story of Wi-Fi is an interesting one. The early security mechanisms used with 802.11 networks had several limitations and eventually led to the development of stronger wireless security technologies. Recap: 802.11b transformed Wi-Fi with faster 11 megabits per second speeds, adaptive rate selection, and affordable wireless access. Despite 2.4 GHz interference and early security limitations, it made Wi-Fi practical for everyday use and laid the foundation for all modern Wi-Fi standards. Which 802.11b feature do you think had the biggest impact on making Wi-Fi mainstream? 11 megabits per second speed, the 2.4 GHz unlicensed band, adaptive rate selection, or CSMA? Let me know your thoughts in the comments. In the next video, let's discuss why Wi-Fi moved to 5 GHz, the story of Wi-Fi 2.